Last year at EmberConf, I talked about small steps that we can take to make our projects maintainable and extensible. Today, I'll describe one of these steps in detail, namely how to move add-ons from one repo to another while converting them to V2. Let me give you some context. Up until 2 years ago at Clark, we were having several issues because we had too many packages. We couldn't move forward with introducing Ember version 4, version 5, Glint, Embroider app, and V2 add-ons. So I decided we have to escape. I'm going to create a new repo where we can do things right. My solution sounds like a paradox, doesn't it? Because I'm asking my team, and by extension you, the audience, to write add-ons not in the repo where the app lives, but somewhere else. Shouldn't this extra step increase development time? And I claim that it's the opposite, because we can solve many tech debts at once by having a second repo. And to prove this point, I'm going to show you how to create a monorepo with as many V2 add-ons as you want. Now for this to work, you're going to need a package registry like npm so that you can publish and install add-ons. I'm going to assume that for this talk you have one already. You're going to also need to know a bit about how add-ons and monorepos work, and that I can teach you. What you're going to need the most is to believe in yourself and others. After all, moving a mountain of add-ons isn't a job that can be done alone. But together with your team and this community that we have, I believe that you can move forward and bring a positive change to your projects. So I want to walk you through the solution step by step. So I divided the talk into 3 parts. First, we'll start out simple and move just one V1 add-on into a monorepo, then convert it to V2. Next, we'll try to create more V2 add-ons and see what problems arise. And finally, we'll see if all of us can create monorepos to replicate success. Yeah. So let's get started. In my talk last year, I highlighted that we can achieve something impossible when we do things in increments. So instead of converting a V1 add-on straight to V2, we'll take a few steps to better understand how to migrate code. Now, one of the reasons to move away from V1 add-ons is a lack of separation concerns. If you use this Ember CLI to create a V1 add-on, you get a simple repo with one package JSON. And because there's room for only one package, the files for the add-on, they're interspersed somewhat randomly with files for the documentation side and files for tests. And because the dependencies for the add-on are mixed with the dependencies for the documentation side and tests, it can be hard to update dependencies. When an Ember try scenario fails, it's hard to know whose fault it is. Was it the add-on, the documentation side, or some test that's incompatible? We cannot tell right away. So it's time to separate. A monorepo allows us to have more than one package in the repo. For example, an add-on that only does the add-on stuff, and a test app to test the add-on. If you want a documentation side, we just create another Ember app. And now that we have separate files, converting the add-on to V2 is easy, at least in theory, using diagrams. So now you have a few choices when it comes to package manager. For this talk, I'll recommend PNPM because it's strict about dependencies. If an add-on is missing a dependency, you'll know right away from failing add-on, docs-app, or test app. I also like the flag -r, recursive, as someone who has to maintain many repos. The output from PNPM helps me easily see which dependencies are outdated and where they're used so that I can decide to update all of them at once, or maybe some of them. You really don't need tools like depend-about and renovate. Anyway, you can create a monorepo with PNPM by telling where the packages are, either explicitly as shown here, or with wildcards. Then you tell one package to depend on another by using the workspace protocol here. So the workspace start on line 6 means that the test app depends on the add-on, and I want to use the exact version. And that's it. It's very simple, isn't it? Now that we can create more than one add-on, here's an interesting idea: to create many docs app and test app for just one add-on. When should we and should we not do this? I'll give you some time to think about it. So if you look at some of the add-ons that I maintain, like Ember Intel and Embroider CSS modules, you'll see that there are many apps. And the reason is these add-ons can be used in many ways, either through configuration or project type. And by type, I mean it's a consumer, a classic Ember app, V1 add-on, V2 add-on, embroider app, engine. The list can go on, and I want to make sure that these add-ons work everywhere. When else can we create multiple apps? I wonder, maybe, to create multiple apps to test add-ons as different screen resolutions like mobile and desktop as a workaround of limitations of Ember key unit. This might simplify how I'd have to test Ember Container Query right now in 9 resolutions with just one app without taking the window size by stubbing code. The workaround is quite brittle, and I would like a better solution. What you don't want to do is to create multiple apps to test multiple versions of a dependency, because for that, we can simply use Ember try. In summary, to move just one add-on, you create a monorepo, then create 3 packages, a docs app, test app, and a V2 add-on. What I completely ignored is how to configure linters, test suite, CI, and documentation files like README and changelog. Step 3 can be the most difficult, especially if you're new to maintaining projects. Let's assume that we have a monorepo that works, because then the rest is easy. We just move the code over. Now, if you don't want a new repo, you can run ember codemod v1 to v2. The codemod can separate the files for the add-on and test, but it's up to you to fix the project afterwards. So how about this idea? If someone else can create the repo for us, all we'll have to do is move our code. Wouldn't that be nice? So now that we know how to create a monorepo, let's dive into how to move code from a V1 add-on in the old repo to a V2 add-on in the new one. Again, we want to do things in increments so that we don't have to move everything at once in a giant pull request. We can guarantee incremental migration if our V2 add-on is backward compatible. And by that, what I mean is how we do things in V2 is in harmony with how we do things in V1, and it allows our apps to consume the add-ons without breaking changes. For example, source code like components, helpers, modifiers, and so on, in V1 add-ons, they used to live in the add-on folder, and these files were re-exported in the app folder so that our apps can use them. In V2 add-ons, we place source code like this hello component in source, src. One moment. Then in package.json, we add a line to the field ember add-on app.js so that we can re-export the file and support the classic behavior in apps. And finally, we can configure rollup to add those lines automatically. But I would say this problem was easy and had been solved eons ago, especially by Simon in his blog post. What I want to focus on are a few problems that many of you will encounter, but to which the solution is lesser known. There can be many solutions to these problems, but the patterns that I'll introduce, again, are designed to achieve backward compatibility. So first, add-ons can provide a bearer file and a template registry. The bearer file allows consumers to import things without having to remember and type the full path. It encourages consumers to use template tag to write their components, routes, and tests. On the other hand, the template registry helps consumers who don't use template tag yet, but they do use Glint to type check templates in HBS. For example, so thanks to Glint, consumers can see where things come from, that the hello component comes from my add-on, and how to use them. Render hello without arguments and attributes. To achieve backward compatibility, all you have to do is to list these 2 files under public entry points in rollup so that consumers can import the files. As an aside, technically, we don't have to list these 2 files because at the moment, Embroider considers all TypeScript files in source along with HBS, GJS, and GTS. I don't like configurations that are implicit, so I recommend that you list explicitly the source files that consumers can import. Second, add-ons can provide styles. A good practice in V2 add-ons is for components to import styles and for the add-on to process these styles, so that at the end, consumers get vanilla CSS and don't have to do additional processing. It's like compiling TypeScript so that we don't force consumers to use TypeScript as well. Embroider CSS modules and Glimmerscope CSS both take this approach. There's some rollup plugin that produces vanilla CSS, and that's why Embroider CSS modules from V2 add-ons can coexist with Ember CSS modules from classic Ember apps, V1 add-ons, and engines. Third, add-ons can provide translations for Ember Intl. either in a single file, as shown here, or in many files using nested folders. Just like in V1 add-ons, we'll create a folder called translations so that Ember Intel can achieve backward compatibility. Then in our components, we can use helpers and the Intel service like before. If you think about it, I think it's amazing that we can, even though Ember Intel is a V1 add-on, we can already use it in V2 add-ons. I think you got to send major props to the embroidery team for achieving this kind of compatibility. Now, in V1 add-ons, Ember will somehow bundle the translations folder during publish, and actually don't know how this happens. But in V2 add-ons, we publish translations by listing in the files field. This is a standard in package JSON, and I can understand that. And number 4, add-ons can provide static assets like images and icons. Just like in V1 add-ons, we can create the folder public assets and refer to an asset by writing a URL that is namespace. So for example, line 7 here, it shows that the namespace can be the package name, my add-on. Then, just like translations, we'll publish assets by listing the public in the files field. But what really glues things together is the field below Ember add-on public assets, which maps the relative URL to the namespace, the relative path to the namespace URL. And we can tell rollup to update this field automatically. And then last but not least, add-ons can provide test helpers. In V1 add-ons, test helpers live in the folder add-on test support, but consumers would write test support instead. There's some Ember magic going on. So in V2 add-ons, we'll name the folder test support so that consumers don't have to change their paths. We can also create the barrel file test support.ts. Here is an example of a test helper that makes use of an assertion from QUnitDOM. And if you want, we can also import Ember test helpers to perform a sequence of actions. So here's a fun fact. We know that Zoe exists because Kate is sitting over there, but our users don't know that. So I think that's why we have to write this test. So deadpan joke. Now, there are 3 things to watch out for. First, to make Embroider and PNPM happy, we need to list QUnitDOM and Ember test helpers as peer and development dependencies. Second, to make TypeScript happy, we need to import QUnitDOM and unpublished development types. And then we need to tell rollup that the barrel file exists. So all in all, I would say that incremental migration is easy, and it's also easy to achieve, also easy to do things in V2 like we did in V1. What makes migration hard, I think, is the project configuration. So we have to ask ourselves again, can someone else create the repo for us? All right, now that we know how to create one add-on, let's try creating more. In math, problems get interesting when you look at it from the higher dimensions. In higher dimensions, we can generalize solutions and validate assumptions that we have made in lower dimensions. And the same holds true for monorepos. We need to check that our solution for one add-on can be extended to work for many. To do so, we're going to look at these 5 questions. Each of these questions asks us to revisit our assumptions and then to come up with a generalized solution that's easy to implement, maintain, and extend. First, how should you set up the repo? We can definitely use the repo with one add-on, then create more under the packages folder. But after add-on number 3, you'll start wondering, should I have shared configurations for linters and rollup? Maybe a doc step and a test step for each add-on. And high-performance tools like high-performance tools like Lerna, TurboRepo, and Ember Exam so that we can lint, build, and test add-ons faster. And to help answer those questions, here is a checklist from my talk last year. Code, and by extension projects that we can maintain and extend, satisfy 3 things. They have a minimum API, meaning there are few variations. They separate concerns, so they only do what they're supposed to, and they have few dependencies. In math, we call these necessary conditions. If one of these conditions isn't met, we cannot maintain and extend the code. So what does this list mean for our setup? Well, for one, we do want shared configurations for linters so that every add-on is linted the same way. And the same goes for our apps. And this way, if there's an issue with one of the add-ons, we can eliminate linter configurations as a suspect. When it comes to rollup, though, I would avoid creating a shared configuration because V2 add-ons are still in flux, and each of these add-ons will likely have different needs. Here, I think it's better to go with duplication, but again, with few variations. And when it comes to separation of concerns, I think we already achieved it by having a separate apps for documentation and testing. We could try to achieve an even greater separation by having these apps for each add-on. But you can imagine that the cost will be too high. If you have 10 add-ons, that's 20 Ember apps to maintain, and possibly 80 Ember try-scenarios to run in CI. We can cut this quadratic cost to a constant, maybe logarithm at worst, by having just one doc7, one test app that cover all add-ons. And lastly, we want to minimize the number of dependencies. Again, because V2 add-ons are in flux, and we don't know how these dependencies will interact with the V2 add-ons. The fewer dependencies that we have, the faster we can adjust the changes made outside, such as in the embroider repo, and the less likely that things will break over time. So we're going to say no on extra dependencies like Lerna, Turbo Repo, and EmberExam, at least for the beginning. Instead, we can rely on simpler tools like Concurrently, PMPM Filter, and Ember Test. Question number 2, can we somehow know in advance which add-on or which file to extract first? In an ideal world, dependency flows in one direction, so we extract the packages that are leaf nodes first. In other words, packages that don't depend on other packages in the same repo. But in reality, the packages are very tightly coupled because business logic changes constantly. These domain abstractions, they assume a fixed point in the past, and ultimately it's humans who write code and introduce mistakes. So we need a way to find out which files and which add-ons we can extract first. And here's where math comes to rescue. I'll illustrate the idea by focusing on components. So recall that code that we can maintain and extend satisfies 3 things. They have a minimum API, they separate concerns, and they have few dependencies. What we can do is to write a code mod that finds all add-ons in the old repo, analyzes components, and assigns them a score between 0 and 1. If our scoring algorithm is good, then we should see a bimodal distribution. That means that we can identify components that are easy to extract and components that are too hard at the moment. After running the code map, we cut off the list, then ask our team to extract the easy components first. Once that's done, we run the code map again, find the next set of extractable components, rinse and repeat, iterations. The math definitely involves magic coefficients that can work for one project, but not others. So I have this thought experiment. Maybe we can introduce something like supervised learning to let each project refine these coefficients over time. Can you imagine a company specializing in code analysis and machine learning, but just for Ember.js? If you have more Ember companies, I think this product will sell like hotcakes. Next, we want to know if every package in the old repo is declaring its dependencies right. After all, we don't want to be surprised when moving code from one repo to another. In addition, fixing the dependencies now can help us later when it's time to introduce embroider and PMP in the old repo. The problem is with Yarn version 1 and tightly coupled packages, it's easy to list wrong dependencies. There's no feedback because the app can build and run even when an add-on is missing a dependency, as long as it gets pulled in from somewhere. Here's where code must help again. We can find all packages, analyze every file that is relevant, then compare the dependencies from the source code to those listed in package.json. From the difference in sets, we can tell which dependencies are missing and which are unused and can be deleted. Even when things are implicit, there's ambiguity in double curly braces, module resolution service injection. We can guess the origin with high accuracy thanks to Ember's strong conventions and an add-on ecosystem that is long established. But it doesn't really help if I'm telling all of you to write your own code mod, does it? It's like telling you to draw the rest of the owl. So here's one that you can run starting now. Analyze Ember project dependencies. You run the code mod on any repo, then review the output. It's quite fast because it analyzes Clark's repo in 25 seconds at 0.2 seconds per package. While our code mods are running, let's take care of releases. If you want to publish many add-ons fast, we only have 25 seconds. You have to make sure that the release process is organized. So first and foremost, we'll enforce semantic versioning in every package independently so that consumers know what to expect, whether there's a small fix or feature that can be merged right away, or a breaking change that requires extra attention. Second, because add-ons can depend on each other, it's actually tricky to update versions to meet semantic versioning. So what we'll do is to add change sets or labels of pull requests, then rely on some tool to update the versions for us. And lastly, because add-ons can depend on each other, we'll want to publish often and consume new versions right away. Otherwise, you can create dependencies between pull requests in the old repo, and these dependencies can be harder to resolve the longer you wait to merge the PRs. But the good news is there are a few ways to remove these PR dependencies. First, you can create releases that can be merged right away, such as fixing styles and translations, adding code that is not used in production yet. You can patch add-ons in the old repo so that it uses a new code, but would sit with the current versions. You can use symlinks, so connect the two repos to test the add-ons before release. And finally, if everything goes wrong, you can always revert code and release new versions. To summarize, you might see an overarching theme to these 3 points. Communicate, communicate, and communicate. Let your team know what can happen in the release, and if there's an issue, provide assist. On a related note are get tags. Get tags mark a specific point in the repo's history and are usually created at the time of release. Thanks to these tags, we can easily send people links and point to specific code. We can also compare tags to see how files have changed. Now, creating tags seems to be a challenge in monorepos because we can release many packages at once. Some repos like definitely typed and tsconfig basis, I feel like they seem to have given up because they never create tags, and don't do that. Others like Embroider and Prometheus Helm charts create a tag for each package for each version. I personally don't like this because we're creating a quadratic number of tags, and it makes it hard to compare. It makes it hard to use the tags to compare the repos. Like, how are people supposed to know which package and which versions to select unless they have ample time to follow the project? There's actually an easy way to create just one tag, no matter how many packages, and give it a name that resembles a semantic version. The solution involves letting the workspace root version indicate the state of the whole project. And afterwards, we simply set the tag name to be the workspace root version. I'll show you 2 ways to update the version starting from 0, using what I call increment by 1 and highest version. So here's how they work. Suppose we have a monorepo with 5 packages labeled A through E. The current version of the workspace root is 0.016, as you see on the bottom right. With increment by 1, we add 0.01 to the current version, no matter which packages are updated. So the tag name becomes 0.017. This algorithm is very simple, but the version doesn't really tell us how mature the project is. The number 17 means that there were at most 17 releases. How stable the packages are, we can't tell from this number. Another way to measure the project state is highest version. This time, we increment the current version by 1, then set the final version to be the maximum of all the versions, so 041. Here is another example. Suppose the package B has a minor version, a minor release. So this time, the maximum is 050, so we set the tag name to be the 050. We can see that with the highest version, assuming that every package is following semantic versioning, the workspace root version acts like a semantic version for the whole project. This solution is not new. The mathematicians studied norm spaces centuries ago, and I'm using their knowledge to make our life simple. Now that we have a single tag, we can send links and compare tags again. But math is hard, you might say. So I wrote a code mod, update workspace root version, that can run either of these algorithms. All you have to do is to install it as a development dependency and run it before you create a tag. And the last problem that we need to solve concerns time, the fourth dimension. Recall that we are migrating code in increments. Since embroidered add-on blueprint is subject to change, the add-ons that we create at a later time can have quite a different setup from those that we had created earlier. When these add-ons look different, our developers will have a harder time jumping from one add-on to another. And when there's an issue with one of the add-ons, we waste time by comparing the setups. So the way I'm going to fix this is to fix time by having a copy of the blueprints. When it's time to create a V2 add-on, we use our copy. And when it's time to update the setup, either by updating dependencies or some configuration, we upstream the change to our copy. It sounds cumbersome, but this will save you a lot of trouble throughout development. On one hand, I think it's better than forking because you can test the add-on, test the blueprints right away. And on the other, you can tailor the blueprints to meet your needs exactly, and we can simplify Embroider's blueprints to target the 80% case. Let's be honest, I took many steps to move the add-ons to a new repo, and you might wonder, is it worth it? Well, 2 years ago, when we were overshadowed by packages and add-ons, our CI would take half an hour to run. Updating dependencies was a nightmare because I needed to think about 190 packages. After a year, around the time when I gave a talk at the EmberConf, we were down by 31 packages and enjoyed a faster CI. We were still at Ember 328, but we could start moving add-ons and discover good practices. In the year after that, we kept moving more add-ons and removing unnecessary ones. With much fewer code around, we were able to update Ember to 4.12 than the 5.8, and our CI got even faster. And mind you, I didn't cheat the number by, if I could pay for more resources in CI or performing some esoteric tricks in Ember exam and CI. This is just good old refactoring and making the project simple. And in our new repo, thanks to Ember Try and Percy, we can prove that our code there will work in the future when it's time to introduce embroider in the old repo, and when it's time to refactor the refactor V2 add-ons even more. The docs app can be deployed in a couple of minutes, so designers and managers can check the components easily and provide developers feedback. And right now, our CI and publish do take a while, and that's because our implementation is naive and it builds all the add-ons just to be safe. I think in year 3, I hope to look into the high performance of the tools, maybe caching and filtering. But what I find to be the most rewarding is that even when a project was behind, we could discover good practices and share them with you and the rest of the community. Because I want you to know that regardless of the project state, there is a place in Ember for you to contribute. And now that we have a working recipe, I want to empower everyone to use it. If we can all create repos, add-ons, docs, and test apps in the same way in less than a second, I think we can file bugs with reproductions more easily. We can convert more V1 add-ons that are open source to V2, and we can accelerate the adoption of embroider apps. And to make this happen, I wrote a code mod again. Yeah. With Create V2 add-on repo, you can create a repo with as many V2 add-ons as you want. The repo that you get is a closed system. This means that to create and maintain V2 add-ons, it doesn't require extra dependencies like embroider add-on blueprint, gember, ember CLI, and ember CLI update. To create an add-on, you run the command new from the workspace root. It's similar to how you use ember new to create an app. After you install the add-on's dependencies, you can run generate anywhere inside the add-on to create components, helpers, modifiers, services, and utilities. The code mod, in addition to creating source files with signature for Glint, the code mod will take care of updating the template registry and the barrel file, and it'll take care of creating the test file in the test app. You'll never want to go back to creating these files manually and typing code that are often case sensitive. And of course, where there's generate, there is destroy to remove all evidence. You might wonder, how do these commands work? In the repo, you get a code mod called blueprints v2 add-on. And here's another fun fact. Create v2 add-on repo was created from another code mod util CLI, and its output bears a code mod, blueprints v2 add-on. Think about it, there's some alien inception thing going on here. So anyway, these blueprints, they're yours, so you can change them however you like to meet your needs. But if you want to stay close to the default, then you can run update blueprints to get the latest version from me. You can definitely see the influence from Ember CLI update, but I mention it again, Ember CLI and Ember CLI update are not used here. Now I'll tell you why shortly. Higher dimensions, more problems. But the first two are more for me to solve as a maintainer of Create v2 add-on repo. It's the last two where I want you to take action. You might have noticed that we lack documentation and tutorials for v2 add-ons. The Ember guys and Ember CLI guys don't mention what v2 add-ons are, and it's up to individuals to find out common migration patterns like the ones that I showed you today from RFCs, maybe the source code in Embroider, the repo, and Discord, where it can be hard to search messages because of fuzzy searching. If you want Embroider to be a success, I think we need to write down what we know and make it easy to understand and find for everyone. A larger scale project, I think, is to reconsider how we do blueprints. Right now, the blueprints for classic apps, V1 add-ons, V2 add-ons, and Embroider apps all rely on Ember CLI update in the name of composition. And I think composition comes at a high cost right now because these two dependencies are 7 years old, maybe older. They have many dependencies in return, meaning many failure points. They grew in size to support more features. They have 0 types, and they discourage change due to slow CI. Given that, Create v2 add-on repo provides a complete solution for v2 add-ons without Ember CLI and without Ember CLI update. I think it's worth asking ourselves, in Ember CLI, can you separate blueprints from the part that actually runs an Ember app? Because by removing blueprints and other unnecessary files, I think we can reduce the package size, which is 1.23 megabytes right now, by 1/3, and make installing Ember more attractive. Are there modern solutions for composing blueprints? Should we do composition at all when duplication could be cheaper? So in closing, I want to thank my front-end team because they're really the ones who are moving the mountain while delivering features, fixing bugs, and giving me feedback on our new repo. If you want to know what I like to work on, you can follow me on GitHub. And if you have more interesting problems that we can solve together, then just come talk to me here, or either here or on Discord. Thanks.